Today's daily LeetCode problem of the day is target sum number 494. For this problem, we are given an integer array called nums and an integer called target. We want to build an expression out of our numbers by adding either the symbol plus or the symbol minus before each integer in our nums array, and then concatenate all the integers together. So for example, if our nums array is simply equal to 2, 1, then we can add a plus before 2 and a minus before 1, concatenate them to get plus 2 minus 1, which is going to be equal to 1, because we have a positive 2 and a negative 1. We want to return the number of different expressions that you can build while we evaluate to our target value. So we wanted to calculate the total amount of expressions. Basically, if we look here at example 1, if we have 5 numbers, then we can do -1, +1, +1, +1, +1, that equals 3. We can do +1, -1, +1, +1, +1 equal to 3, so on and so forth. Eventually, we will come to every solution where there is 4 plus 1s and 1 minus 1, ultimately equaling 3. So, taking that into code, how are we going to look at this problem? So my intuition for this problem is we can use a dynamic programming approach to solve it. We're going to keep track of, let me pull this over here. We could keep track of all the possible sums at each step and avoid redundant calculations. The problem will boil down to just simply determining the number of ways to partition our array into subsets whose difference equals our target value. So how do we approach that? So my approach for this problem can be broken down into 4 simple steps. So we will first calculate the total sum of our array. We'll then use a dynamic programming table where the DP of each integer, their sum, will represent the number of ways to reach a given sum using the first I numbers. So from index 0 to index I. And then we will iterate through the array, fill up our dynamic programming table based on the choices for each number, either adding or subtracting it from our current sum. Then we can simply return our result stored in the dynamic programming table for our target sum. So I broke down our approach into 5 simple steps. We're going to calculate our total, initiate the dynamic programming table, use our base case, so we'll set the initial state of the dynamic programming table, and then fill our dynamic programming table for each number in the array, and simply return the result if the target is within a valid range. So let's go ahead and jump into the actual code part of this. So for step 1, all we have to do is simply get our sum. So int total sum is going to be equal to our, we can use the arrays dot stream function to separate it into numbers, and then calculate the sum of those numbers. And then we can move on to our step 2. So in step 2, we'll initialize our dynamic programming table. So it's going to be a 2D integer array called DP, and it's going to be a new integer array of length. The first part is going to just be our nums array, so nums dot length. And then the second part is going to be 2 times our total sum plus 1. So the reason we're using that is because, number 1, our sum is created only out of single ones. And this is going to allow us to calculate basically the possible length of the sum, or the possible size of the sum, starting at each index. So we're going to say 2 times the total sum plus 1, because it's 0 indexed. Next, we will calculate our base case, set the initial value in the state in the dynamic programming array. So our DP of 0, starting at our first index, and we'll get nums of 0, because that is the first value in our array, and we will add that to our total sum. The reason we're adding it to our total sum is we're saying, all right, what if dynamic programming of 0 is equal to a positive 1? So it will be equal to 1. The result of that will be 1. if we say that our dynamic programming of 0, the first index, is a -1, so nums of 0 is equal to negative, and then we add that to our total sum, we could say, okay, it's plus equal whatever it was plus 1. So if it goes negative, we will add 1, making it 0. So this is adding the first number. This is subtracting the first number. Those are our two possible first base cases. And if we look and see how we initialized this state, this is going to start in a completely different area than where this is going to start. So I drew out a little example so we can visualize this a little bit better. This is our dynamic programming array. So we have our 4 rows, and then we have 9 columns because we have our total sum is 4 with 4 rows times 2 is 8 plus 1. So we have 9 columns. So if we look over here at initializing the base case, dynamic programming of 0. We're going to get nums of 0, basically. And then we're going to say, okay, that's why we're here. We're at the first index. Then we're going to take our nums of 0 value, which is 1, and we're going to leave it positive. We're going to plus that by our total sum, which is 4, since we have 4 ones. So that's going to equal 5. So in our dynamic programming array, this is going to be at position 5, and it's going to be equal to 1. So our first value is 1 at the 0, 5 or 0, 5 position. This would be written as dp of 0 of 5. Now we can take a look at our second base case. We're going to say, what if our first number is a -1 instead of a +1? So -1 plus 4 is 3. So we're still in row 0, but we're going to be in column 3. So -1 plus 4 is 3. And we're going to plus equal 1 to whatever value is currently there. Currently it's a 0, so plus equal is going to be equal to 1. So now you can see how we have two separate starting points. This is if 1 is negative, this is if 1 is positive. And we're going to do that for each of our numbers, so we could calculate, basically, at each position, if we turn this number negative, or if we turn this number positive, will we be able to reach our target number? So let's continue with this. So step 4 is where we're going to fill our table for each number in our array. And we'll do this by using a nested loop. So where's my mouse? For each integer, we'll call it our index. We'll start at 1 since we already initiated 0. As long as our index is less than our nums.length, index can increment. So considering that we made nums.length the limit for index, we can assume that we're going through the rows of our dynamic programming array. Next, we're going to use this second part of our nested loop. For each integer, sum is going to be equal to, we're going to say a negative total sum, as long as the sum is less than or equal to our total sum, then sum can increase. The reason we're starting at negative total sum is because that is technically the lowest we could possibly go, and we will work up from there. So that's assuming every single number is negative. So if our dp of index -1, meaning the 0 index, that's where we would start officially, and the sum plus our total sum is greater than 0, then we can add the current number we're on to our sum. So dp of our index of our sum plus the nums of index, whatever value is currently there, plus our total sum to get the correct position in the array, will plus equal the dynamic programming position of index, the previous number, so index -1, and sum plus our total sum.
So we're going to take the value at the previous number, get its current sum, and add it to our previous sum that we've calculated. This will basically say that we added the current number to the ongoing sum. Now we have to do the opposite as well, where if we subtract that current number, so dp of our index of the sum minus nums of index plus our total sum. This is just the complete opposite. We're subtracting instead of adding, but it still gets us to the right position. So dp of index minus 1 and our sum plus the total sum. Efficiently calculating what if we subtracted the current number we were on. And finally, we simply have to return the result if the target is within a valid range. So we want to return our math.absolute value of our target as long as it's greater than our total sum. We will return 0. Otherwise, we want to return our dp of nums.length minus 1 and our target plus our total sum, because that is how many we were able to calculate. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions.